You said it like 30
All right.
Moving on to section 2 today. What I'll tell you is if you ever have questions on big ideas or need help or there's a question you didn't understand or something like that, don't ever hesitate to, before you submit it, just wait and get some help on it if you need some help. So I know there was a lot of vocab and things like that in that first section. If there's any of that stuff that you're struggling with or not really sure about or how to label or use the symbols and that kind of thing, then just let me know. I had one student I was helping the other day, and I don't really know exactly what was going on, but the pictures on big ideas had instead of arrows on some of the symbols, I had lowercase letters. I don't know, it was really weird. So if you get something that weird that shows up on big ideas, just let me know. I'll take a look at it or we'll figure out what's going on. But I'm not sure what was going on there. Okay, today we're going to talk all about segments. We talked about what a segment was the other day. Today we're going to talk about some different things with segments that we can do with it. Okay, one of the most one of the things that we will not do a lot of, and this one is talking about what we call the ruler postulate, where we just take a ruler and we measure something. Okay, we won't do that a lot. When we find the length of a segment, typically we'll use some algebra to get there. We'll find out what x is, and we'll use the value of x to find the lengths of a segment. So we won't typically just take a ruler and measure something. Okay, and that's what this is kind of saying, is just take a good old ruler here. I don't know where, but most rulers have two sides to them. This ruler here has inches on top and then centimeters on bottom. Okay, inches are labeled in quarter or half. So if you measured something, you could say that one is 6.5 inches. And then when you flip it over to centimeters, centimeters are labeled in tenths. And so you could say something like 3.2 centimeters. And so whenever you lay it up here, you put the 0 obviously on the left-hand side, you put this on the right-hand side, and because this is blowing up, this would not be accurate, so I'm not even going to tell you what the length is here, because it's not accurate as to what your paper would be. But you could take this ruler, you can throw it up there and we just won't do that a lot, so I'm not even going to talk much about that. But that's what you would do if you actually had to measure something. It has a couple different things. And there really isn't anything, you could, especially with, you could just Google it and what's the conversion from inches to centimeters. But it's really two different units, okay? Two different, metric is different than the standard unit. In fact, you guys may not know this, but the United States uses feet and inches, right? And we're one of just a few countries in the entire world that use that as our standard of measurement. Almost everybody in the world uses meters, centimeters, and that's when we have the Olympics, or when we host the Olympics coming up in LA in a couple of years, we get to do everything in feet and inches. But if we have the Olympics over in another country, then all of the readings, they're going to say how much did they lift, or how much did they throw, or how far did they throw, and everything's going to be in centimeters instead of feet and inches. And so we are one of the few countries that does, which is kind of interesting.
It's the same thing pounds and kilograms.
Mm-hmm. Pounds and kilograms. Yep, exactly. Okay, this first part here, compare and contrast XY with the segment above it. Okay, we talked about this right here. Okay? If I say XY, then the way that I would read this, and I'm going to put quotes around it because this is the way we would read this statement. The distance between X and Y. Okay. Or we could say, what is the length of X to Y? How far is it? How far are we moving? Okay. So when there is no symbol above it, that means distance. And that's something to keep in mind because we will see that at different points in time. Even as we move into some other chapters, there are times where we will see X, Y without a symbol above it. So now we've seen it with like arrows. We've seen a line. We've seen a segment. We've seen an array. We've seen all these different things. Each one has a different symbol. X, Y with no symbol above it means something completely different. Okay, it's not a segment. It's not an array. It's not a line. It's distance between X and Y. Okay. So if we're trying to differentiate between the two here, X, Y, we talked about this just a second ago, with no symbol above it, is distance, okay? So when it says distance, we would use X, Y. When we are trying to name a segment, we will use X, Y with a line above it. No arrows, just a line. Okay, that's the symbol for segment. If we're talking about a numerical value, if I said what is the length or distance of something, we would use a numerical value, right? So if there's a numerical value involved, it's talking about distance. How long is something? What is the length of something? If we're talking about an actual figure, a piece, a geometric figure, then that would be a segment. The ruler postulate, like we talked about above, when you're actually measuring something, when I measure something, I get an actual distance. And so an actual distance would be XY without a symbol. Okay? So that's what it means by the ruler postulate, is you're actually going to measure the length of a segment. You're going to use a ruler to measure it. Okay. Congruent segments. One of the words that you're going to see a ton in geometry, there's a lot of words that'll pop up a lot throughout the year. One of those words is congruent. Congruent essentially means equal. Okay? So if two segments are congruent, they have the same length. If one of them's 3 feet, the other one's 3 feet. If one's 2 inches, the other one's 2 inches. They are exactly the same length. Okay? Now, when we do this, the way that we will mark this on a picture okay? Let's say we have segment AB and segment CD. If I tell you that this one is 4 centimeters, and I tell you that this one is 4 centimeters, then what we are going to say is that those two are congruent, okay? And if they are congruent, we are going to mark this marking on here, and this marking right here tells me that those two are congruent. I might not be given the actual length of it, but if I see that marking on it, that tells me that they are congruent, okay? So it won't always give you both. It's not going to say, here's the length, here's the marking. If I see the marking, I know they're the same length. If I see that they're the same length, I know I can put the marking on there. So you'll see it different ways. So what we can say here is that AB is equal to CD. This is telling us length. Those two pieces have the same length. AB and CD have the same length. The new symbol that we're going to see today because we know they have the same length, then we're going to say that AB is congruent to CD. So there's a new symbol. And we're going to see this symbol a lot as we go throughout the year. So we need to become familiar with it. It's simply an equal sign with the tilde sign over the top of it. Okay? We call that congruent to. And that's the way we would read it. Segment AB is congruent to segment CD. Okay, on this one here, we're going to plot these 4 points. Okay, now thinking back to Algebra 1, we talked about, we know how to plot ordered pairs, we know how to plot points. First point is J at -3, 4. So we're going to move left 3, up 4. K is at 2, 4. So we're going to go right 2, up 4. As we plot these points, I'm going to go ahead and label them as well. J and K. Then we're going to do L, which is 1, 3. And then we're going to do M, which is 1, -2. Then it wants us to determine if JK and LM are congruent. In this case here, all we have to do to determine the length of JK is count. How many units? 1, 2, 3, 4, 5. So I'm going to say that the length of JK is 5. If your segment is like at an angle, we can't count. Okay, but as long as it's horizontal or vertical, we can count up and down or left to right. And so here we would also say LM is 5. So the length of both of those is equal. So we can say that JK is equal to LM. Therefore, segment JK is congruent to segment LM. Okay. How we say it, the symbols that we use, the way that we write it is pretty important. Okay? This is telling me the length is equal. This is telling me the two segments are congruent. Okay? So understand the symbols and understand what they mean. That's a really, really big part of today. Yeah? Okay, because remember what we talked about up above. If it doesn't have a symbol above it, it means distance. We're talking about a number. We're talking about length. How long is that? So that's the way we read it, is the distance.
The distance are equal, and then the distance on the congruent.
Yep, right. So when I use that symbol, I'm saying the two segments are congruent, okay? Do those two things mean the same thing? Yeah, just a little bit different way of saying it. Here we're saying they have the same length, then we say that they are congruent. Yeah. Okay, any other questions there? Okay, segment addition postulate. Segment addition postulate. To kind of give you a visual of what's going on here, I kind of like to use visuals if I can. If I had a straw, I took one of the straws that we had yesterday, right? Here was our original straw, okay? If I told you that this straw was 7 inches long, 7 centimeters long, whatever, okay? And I separated it. If I tell you that this one is 2 and this one is 5, when I put those together, that has to make a total, right? It's pretty straightforward. When they are together, we know the total length. If we separate it, we just cut it, the 2 individual pieces make the total piece, right? So that's what the segment addition postulate is essentially saying. Is 2 individual pieces of a segment add up to equal the entire thing. So I'm going to draw a picture here. So the way that I'm going to write this is I'm going to say that AB plus BC equals AC. Once again, I didn't put a symbol above it, right? Because we're talking about the length of AB, the length of BC, so this piece plus this piece equals the entire piece. If you wanted to think about it with numbers, if I said the length of this one is 2 and the length of this piece is 5, I could say 2 plus 5 equals 7. So the 2 smaller pieces add up to equal the big piece. Okay? That's what we call the segment addition postulate. So this one down here, find DF. Okay, so for this one, the way that I would write this one out is I would say that DE plus EF, because those are the 2 smaller pieces, equals DF. Okay, DE is 23. EF is 35. Okay, we don't know DF, but can we find DF? Yeah, pretty easy, right? Because we know the length of DE, we know the length of EF, so I can take 23 plus 35, and that gives us 58. And that's the length of DF. Okay, so I could say DF is 58. Math's not real hard, just kind of understanding the segment addition postulate. Okay, now on this one, just be careful. Like, we can write this one out the same way. We could say FG plus GH equals FH, right? Same idea. 2 smaller pieces added together to equal the big piece. And some people get confused by the arrows on the end. But even though we have arrows on the end, we are only talking about this little segment right here. It's not going on past those 2 segments, right? 2 smaller ones, and then we got the big one. So on this one, we know what FG is, right? FG is 21. GH, that's what we don't know, okay? And so what I'm going to do here is I'm just going to put like an X right there, because I'm kind of just writing an equation out here. 21 plus something, because we don't know what GH is, so it's an unknown, equals, and then they tell me what FH is. So this time they give me the entire length. They give me one of the small pieces. I got to find the other small piece. So now, is this a pretty easy equation to solve?
36 minus 21.
Just subtract 21. Yep. 36 minus 21. We would get 15. So we would say that GH equals 15. The math itself is not all that difficult, just making sure we pay attention, read the problem carefully as to what we're trying to do. Okay, on this one here, I feel like we use our phones for maps anymore, right? And so we don't ever look at like I remember going on trips when I was younger, and we had this big physical map out, and hey, just quit messing with other people's stuff, both of you guys, okay? And we would look at it, and the map has like a key of saying how long it is. So like from city to city, then everything has to be based on the same length, right? If I would look at it, and the distance between Lubbock and Tulsa is a little bit further than the distance between Tulsa and St. Louis, then it has to be to scale, basically, right? And so when you look at it, you could figure it all out, and you could figure out how long and how many miles it would be to get to a certain city. And so that's what we're looking at here, except they actually go ahead and tell us the actual distance here. We're trying to find the distance between Tulsa, Oklahoma, to St. Louis. Okay, so this is the piece that we're looking for right here. T to S, Tulsa to St. Louis. We know the distance from Lubbock to Tulsa. Lubbock to Tulsa is 377. We don't know the distance from Tulsa to St. Louis, so that's my X. From Lubbock to St. Louis is 738 miles. Okay, now some of you might look at this and say, do I really need to set up this equation? I know that you could probably do it without the equation in most cases, but I think it helps just to kind of set it up, see what's going on, understand what's going where, and then kind of like we did on the last problem, we're just going to subtract 377 from both sides and 361. Okay, now this one takes it a little bit different direction, a little bit different type of question that's being asked. If the trip takes 6 hours, how fast are you driving? Okay, and so if you think about if you're out driving in a car, okay, how do I usually judge my speed? Miles per hour, right? And so when I say miles per hour, an easy way to figure that is we take miles divided by hours, okay? Per means divide. So miles per hour means miles divided by hours. Okay, so if we're going from Tulsa to St. Louis, we would take the 361 and we divide it by 6. 60, okay? What's the decimal?
0.16.
Okay, so 0.2. Okay, and what you might say is, well, that's not very fast, right? Probably not. And I don't know if there's an interstate. There probably is an interstate that connects Tulsa to St. Louis. I don't know that for sure. So you're probably driving faster than 60 miles an hour, but that's our average time to get there over that whole 6 hours, okay? So if you're out driving, do you usually drive 6 hours straight through? Probably could, right? But probably not, okay? So probably going to stop, get something to eat, go to the restroom, get something to drink, whatever it might be. You might take 1 or 2 stops to get there. And so that's your whole average, because all of that time, 6 hours was the total time to the trip, okay? And so if you did drive straight through, it probably wouldn't be 60 miles per hour. It'd probably be a little bit faster than that. Okay, I'm going to skip over the bottom one because there's not much difference there. It's a problem. Okay, we got a big segment here that's broken up into smaller pieces. So we got AB, BC, CD, and then we got big thing 80. Okay, so we want to find the length of all of these different pieces. What I like to do is label on here the pieces that we know. So from A to D is 40. Okay, the next thing it says is AB and BC are congruent. What's that tell me about AB and BC? They're the same length. And so remember that little symbol we talked about just a second ago or earlier in the lesson? AB and BC are the same length, so I can make that little marking on there, and that tells me we know that those two are the same length. Okay, we also know that AC and CD are the same. So I could say these two are the same. And I know that's kind of hard to mark on your picture, but for the sake of doing it up here, I'd do a different color so you can kind of see it a little bit better. Okay, so first up, if AC and CD are congruent, and this whole thing is 40, then what is the length of AC and CD? 20, okay? So AC is 20, CD is 20. You don't necessarily have to go in order. And the reason I go there first is because now AC is here, and we're saying that AB and BC are the same length. Well, we know now that AC is 20. So when I split this one in two, I'm taking 20 and splitting it in half. And so I know that AB and BC are both 10. Okay, BD. Let me just get rid of all that. Okay, so I'm going to label all this on here. 10, 10, 20. BD goes from here to here. So B to C is 10, C to D is 20. So there, the segment addition postulate, we know we can just add those two together, and that would give us 30. And then finally, we already, that part we were given. That's the easy one. Okay, what is the probability? Here's another one. We haven't seen probability for a little while. Probability is success over the total. Success is getting what we want to happen. Okay? If I rolled a die and I said I really want a 2, okay, or I want to find out what the probability is of rolling a 2, and I roll the die and I get a 3, is that a success? No. Okay? But if I roll the dice the next time and I get a 2, is that a success? Yeah. Okay? So get what we want. Okay? We want to get what we want. So first of all, let's focus on the total. How many total segments are we looking at up here? How many different segments did we have listed out here? 6. Okay? 6 that we have listed. Out of those 6, how many of those 6 would be considered a success? Well, that means it has to be greater than 10.
4.
Yep, 10's not greater than 10, not greater than 10. These 4 here are greater than 10. So 4 out of those 6 is greater than 10. And so we would say always reduce 2/3 of those segments work. Okay, so we always reduce if we can. Okay, this last one is a little bit tricky, and it kind of brings up it's one of those things in geometry that how do I approach it? How do I think about it? And I would say most of us would think of it one way, but we don't think of it the other way. Okay, and a lot of times, or at least sometimes, there's more than one way to look at the picture, and we don't have a picture given to us, so that makes it difficult. So drawing yourself a picture is a really important part of this problem. Okay, points A, B, and C fall on a line. And so probably the way that most of us think about it would be something like that. Okay, and it doesn't necessarily say that B is in the middle or any of that kind of stuff. But what we do know is AB is 5. We know that AC is 7. So what would the length of BC have to be? 2. Okay? And that's what it's asking us is what are the possible values of BC? Okay? Well, then we got to ask ourselves, is that the only length that BC could be?
No.
Not necessarily. So what else could we do?
12.
Okay, how come?
Because you would
put C in the middle. Okay? Does that help us? If I put C in the middle, if I go B, C, A, does that help us? AB is 5. AC is 7. Does that work? If the whole thing is 5, can AC be 7?
No.
No. Okay. So you're right. C could be in the middle, but as we look at the actual lengths, that wouldn't make sense, right? So that is one way you could look at it. So that's a good thought. Okay. But number-wise, that doesn't match, right? Doesn't work. Okay. So what else could be in the middle? A. Okay. So let's go B, A, C. Okay. Here we know that AB is 5. We know that AC is 7. And we're looking for the length of BC. Okay. Braylon, what do we get? Hey. You had it right. Did you understand why it was 12, though?
Yeah.
How come?
So that added them together.
Okay. Does that always work?
Sometimes.
Sometimes. Okay. For this one, it does. You're right. Okay. So those would be the two possible answers. 2 and 12. Okay. 2 and 12. So when it says what are all possible values, there's probably more than one answer. Okay. For this one, all we had to do was add them together and subtract them. But drawing yourself a picture probably wouldn't be a bad idea. Okay, that's our notes for today, guys.